For my statistics project, I was tasked with testing a hypothesis, so I decided to test how popular the iPhone really is. In order to do that, I had to come up with my null hypothesis, so I decided to test if more than 50% of my senior class owns iPhones. For this, my null hypothesis is p equals 0.5, and my alternative hypothesis is p is greater than 0.5. My alternative hypothesis is what I think that the test is going to give me, and the null hypothesis is what I am testing against. So in order to collect the data, I surveyed people from my senior class, and I wanted to avoid just surveying people in my AP or honors classes. So I made sure to survey people during lunch and during classes that all seniors have. I did this to make sure that the sample that I got accurately represented the population of seniors at my high school. I found that 40 of the 50 own a phone and 10 of the 50 do not own a phone, so the sample proportion is 0.8 and the sample size is 50. Now I had to make sure that my sample size was large enough for my numbers to be accurate, and so in order to do that, I did n times p, or 50 times 0.8, and got 40. And I did n times 1 minus p, or 50 times 1 minus 0.8, and got 10. As long as both of these numbers are greater than or equal to 10, my sample size is large enough for my numbers to be accurate during the math. Now I calculated the z-score, which is done by subtracting the proportion you're testing against from the sample proportion that you got, and then dividing it by the square root of p times 1 minus p divided by n. So putting all my numbers in, you get 0.8 minus 0.5 divided by the square root of 0.5 times 1 minus 0.5 divided by 50. And after doing that math, you get that z equals 4.24. Now you have to compare z to the critical value. So we take our confidence level, which is 95% or 0.95, and we use it to find the critical value on the critical value chart for z-scores. And you find that the critical value for the 0.95 confidence level is 1.654. We found this because we were looking for a right-tailed test rather than a left-tailed test or two-tailed test. And so I'm using a right-tailed test because I'm trying to test whether p is greater than 0.5. So if z is greater than the critical value, we reject the null hypothesis, and 4.24 is greater than 1.654, so we reject the null hypothesis. We also wanted to test it using p-values, so I put the numbers in the calculator and got that p equals 0.000011, and we can compare that to the a. So a is found by subtracting the confidence value from 1. So 1 minus 0.95 gives us 0.05. 0.00001 is smaller than 0.05, and so that means we reject the null hypothesis. So rejecting the null hypothesis means that we agree that our alternative hypothesis is correct if p is greater than 0.5. This means that there was enough statistical significance in our sample proportion and the numbers that we got from our sample to say that the population of seniors at my high school, more than 50% of them own iPhones.